Hey guys! So, in this video you and I are going to talk about the broken window principle. What it is, how to avoid it, and what I think if you have the character and the strength of will to do it, what you should be doing to help the situation. So let's get into it. Now, the broken window principle is basically a term within programming which states that if you have messy code, if you have any code at all that is messy, or a region of code that is messy, and you don't clean it up as soon as you find the problem, it's going to get worse over time. And that's what the broken window, it's basically the idea. If you see one broken window on a building, it lowers the perceived value of the building and people stop caring about it. It's like a rough neighborhood where, you know, the rougher, like the less you care about keeping up appearances, the rougher it gets. It degrades over time because you're not maintaining it, basically. And this happens in code quite a bit. It's actually one of the most important main reasons why I made a video a while back where I was saying that to me one of the most important principles in programming is loose coupling, because I know from experience that code change. Sometimes you write good code, sometimes you write bad code. The only really dangerous part is when you have bad code that is very central to the life to the life of your application, the backbone, if you will. If the backbone or the keel of the ship is bad, everything else rots from it. That's why loose coupling, in my opinion, is so important, because with loose coupling you can afford to not write perfect code every time you sit down and write something, because it's in theory very easy to change it. That's what in my opinion, what you should go for: disposable code, things that are easy to change and throw away and change whatever, and never be personal about code. Everybody has, you know, you write your thing and somebody comes along and says, hey, can I rewrite this? Then you should just go, yeah, sure. Keep them an emotional distance. That's my tip anyway. But because what happens when you have a broken window or a piece of code that is not so nice is that depending on the person who comes to the code next and needs to change it, they're going to do what I call shim programming. And shim programming, this is probably, I don't know if it's my term, but basically the idea is that you can have a really large ugly function, and because it's so ugly, and the person who is going to go there and change something, they don't have the energy, the time, or whatever. This is actually one of the worst parts about being a programmer, because for some reason people outside of IT don't understand that, you know, if the worse the code gets, the longer everything takes to do, because it's the problem, but it just grows and grows and grows. They don't understand, like, for them it's this magical thing, like a car, you know, that it's always good, or whatever. Yeah, take a car for example. A car will always run at the same speed regardless of, you know, who's driving it, basically. But that's the issue in coding. That's not how it works. It works the way that if you don't maintain it, if you don't take care of it, and in car terms that probably is true as well. If you don't take care of your car, it's going to break down sooner or later. But in code, the code doesn't necessarily break down. It just takes longer and longer to do stuff. So what happens is that they do shim coding. They start shimming in their own functionality inside of the code. So fixing their problem, but also making the code even worse. And this has a snowballing effect. People keep on doing it until the code is so ugly that some junior developer comes in and says, hey, we should rewrite this. And all the seniors go, ugh, yeah, sure, we should, but we're not going to. And we're not going to because it's too much work, it's too much risk, and it is too much work, and it is too much risk. So you keep on living with it, and the company will have to, the issue, like the development speed just keeps on going downwards until you have to fix it. Because sooner or later, most likely, you're gonna have to fix it. And by the time you're fixing it, it has cost your companies hundreds of thousands, if not millions. In my case, it was exactly what happened at Ticketmaster, like, rather that's the situation they are in, like, in order for them to make any meaningful change to a very critical piece of their system, they basically have to rewrite it, and that's going to cost them so much, so very, very, very much. But, you know, they have deep pockets, all those hidden fees, you know, Anywho, that's basically what the broken window principle is about, and the issue that it causes. Now, the way that you mitigate it the best is with the Boy Scout, or rather the idea is that you use the Boy Scout principle. And the Boy Scout principle states that whenever you see a piece of code, you ask yourself, can I make this a little bit nicer? And then you change something small about it, and then you're done. That works very nicely for the most part, but it's very tricky to do, and it's something that not everybody does. But it's a very nice thought to have. I personally think that, because I believe that every time you change code, you should be very careful. Because in theory, any change to a system can break that system. So I argue personally that you should only change code that you're touching right now, that is fresh in everybody's memory, that you need to touch, and you should only change it if the code is, you should not change code just because it's not written in the way that you want it to be written. You should change it if it's getting ugly, if it's becoming a broken window. That's when you should step in and refactor and fix things. Because don't just change things because somebody used a object data in JavaScript, object data sign instead of a spread operator on an object to copy something like that. That's just sure, you do it if you want to, but that it doesn't really provide much value. It's just your mental gremlins telling you to do that. So the core problem with this is that it's how it works. Like if you live long enough in a very messy apartment or a messy house, you don't get you stop being motivated to keep things nice and tidy. It's the same thing with code. If the code is ugly all the time and it starts to settle in your developers, they stop caring. They get demotivated. If the project is very nice and shiny, on the other hand, people want to keep it that way. That's actually one of the strongest arguments for having 100% unit test coverage, because if you have 100% unit test coverage, mentally very few people will have what it takes to break that down to like 99% or something like that. That would be like sending somebody a angry emoji or something when you're actually being angry at them, instead of sending a smiley face to kind of mitigate the whole situation, right? It feels wrong. You don't want that. You want to feel good, and breaking 100% unit test coverage, that feels bad. But that's one way. But I would like to say, as a finishing argument, if you are the type of person if you're strong enough, you should be doing this. Don't care about if your colleagues don't care about the code base and they tell you to just hack it together and so on. Okay, sure, hack it together if you have to, but try to write good code yourself without worrying so much about everybody else. Trust me, just try to do a good job. Don't go overzealous. You need to be pragmatic. You need to know what's important and what's not important, and that comes with experience. But don't let people push you into writing really bad software. Try to do your best, okay?